Good morning and blessings to each one of you again today. It's a real joy that we've had to be here in the camp with you so far this weekend. We've enjoyed it. Thank you for your welcome again. And thank you, too, for the gift bag that we had in our room with snacks and things to keep the boys occupied. It was nice of you. And the room that we have is great as well. We'd be happy if one of you would take that nice room, but if you choose to give it, we accept it, and we want to be thankful for it. Thank you for the opening thoughts. Have you noticed, as he was going through that devotional, the difference between what it's like to be with Christ and without Christ, the difference between the new birth, that original earthly existence versus the spiritual existence after we encounter Christ. When we encounter Christ, who is the creator of all these things, it completely changes our life and it brightens every facet of it. And everything has changed because we've met the Creator and we've met the Savior. G.K. Chesterton once said something like this: you can't look at the sun, but without it, you can't see anything else. So we can't look at the Son of God either. We can't look directly at God. There's too much glory there, but without God himself and the Son of God shining his light, we can't make sense of the world around us either. So as God shines through our hearts and lights up the world around us, it makes a difference for us and even those around us as well. So God makes all the difference. Our Creator, our Savior, makes all the difference. And when we look at the things that he's made, now segueing into our topic here this morning, we look at all the different planets in our solar system, and we recognize the variety that's there and the creativity that he has displayed in the solar system around us. Then it makes us understand that God is a creative God. He is an interesting God, and he's full of surprises for us as well. There are surprising things in the solar system, and so in our spiritual lives, there's surprising things there for us as well. A spiritual life is much more than just going to church and what happens there. A spiritual life that's regenerated with Christ goes much deeper, and it permeates every part of our life, and it makes every part of our life more fulfilled, more interesting, more exciting. And so when we look at what God has done in the physical sense as well, we would expect it to mirror some of that. So as we go through our solar system this morning, I want you to notice how creative God is in creating the other worlds in our solar system right here around us. So we're going to stay mostly within our solar system this morning in this session here, and we'll look at how God is a creative creator. And as you notice all the variety that he's made in our solar system, I want you to translate this into our spiritual lives as well and see how that this is the kind of God we serve. It's not a dull and unfulfilling experience as we walk with him, but it is something much richer than that. We've seen how many stars there were last evening. At least we saw some of them, and we kind of explored how many stars there might be within our observable universe. And all that I was talking about last evening was just our observable universe. So that's the distance that we can see. We don't know what lies beyond that. But the innumerable host of stars out there is mind-boggling to us. But now that astronomers have built some other special telescopes like the Kepler telescope that they've launched up into space, it's in orbit around the Earth, it's out there looking for other planets outside of our solar system, they have come to discover that there's most likely more other worlds in our solar system, in our universe, than there are actual stars. So more planets than stars in the universe. Stars are hot, burning thermonuclear furnaces, so you couldn't go there and land on it and explore it. But when we look at other worlds like Neptune, Uranus, there's Saturn, there's Jupiter, Mars, Venus, all these are stars, these are celestial objects that aren't on fire. They're not burning. So for a lot of those, we could go there and look and see how that this other world looks in relation to the earth. So if there are countless quadrillions of stars out there and even more worlds out there, how creative must God be? And what kind of God is he to just make all these things? And it looks like there's no purpose for them other than to just bring him glory. These other planets that we have in our solar system don't have life on them as far as we know. They're more sterile than a hospital environment. Not even the simplest forms of bacteria and viruses are on those planets. So they're just lifeless. But they're there declaring God's glory and bringing him pleasure. Revelation 4:11 says, "For thy pleasure they are and were created." Okay, now I'd like to launch off into this session with one verse from Psalm. Again, last evening we looked at Psalm 89:5. This morning we want to look at Psalm 111, verse 2, I think it is. I'll just quote it. "The works of the Lord are great, sought out of all them that have pleasure therein." This is a verse that's also found over the entryway into the Cavendish Laboratory in Cambridge, England. And this is one of the most famous laboratories in the world. It's where the nature of quantum physics was discovered and the double helix nature of DNA, where they really started to understand what DNA actually is. And there, over the entrance to that laboratory, is this verse, Psalm 111:2. "The works of the Lord are great, sought out of all them that take pleasure therein." God takes pleasure in the things he's created. What he takes pleasure in, he wants us to take pleasure in as well. We're supposed to mirror the heart and desires of God. So as we look at the things he's made, there's lots for us to learn from, and it's lots for us to seek after, and God has a lesson through every one of those things. God is speaking to every one of us at all times. It's not that he only speaks sometimes, but I think he always has something for us in every part of life, and we only perceive it when we stop to listen. So as that laboratory is there, it was interesting how that I think in the last part of this past century, they actually redone the laboratory, remodeled it, but they kept the verse up there, which is kind of refreshing for this day and age where it seems like so many institutions are trying to remove God and every reminder from God, but the verse is still there. And I think there are those who are at the forefront of discovery, pioneering their way into these things, and they realize that there is a greater power there. In fact, Albert Einstein, one of those who looked deeper into the laws of physics than any one of us ever have before or after, he said that anyone who is deeply involved in the study of those things is convinced that there is a spirit manifest in the laws of nature, one that's vastly superior to anything that we know. Now, of course, Einstein had gone through some times in life where he had other ideas, deistic ideas about the universe and the way that God works within it. But he did have some insights for us in a physical way as well. So here we have the topic this morning, creative creator, and we want to look at how these things are in the solar system around us. We'll start off with the sun and the planets that you see here. These are about the proper size or scale with each other, but not at the proper distance. They're almost equidistant from the sun, but in reality, these planets right here are they're fairly close to the sun, and then these planets are much farther away. This here shows you the relative size, though, from one to the next. The Earth is the largest of the terrestrial planets. Then we have the big gas giants and ice giants out here. Then we have some dwarf planets down here as well. Pluto used to be considered a normal planet, but now it's just a dwarf planet, and more on that later on. We can get some parallels and lessons from the solar system. One of them is that, the sun gives light and life to these planets, light to the planets and life to the earth. The Son of God gives spiritual light and life. And the sun is the center of the solar system in the same way the Son of God is the center of the kingdom. And then the planets revolve around the sun just as the lives of God's people revolve around the Son of God. And then finally, the moon is reflecting sunlight to lighten the night, and we reflect sunlight to lighten this dark world that we live in today. So we are kind of like a recipient of the light of the sun, and we're re-emitting it, showing a reflection of the glory of God. In some ways, it's not just a reflection, it's an emission as well. So we're like miniature moonlets, declaring God's glory here on the earth. See if we can get this thing to work here. Apparently it doesn't want to go forward, but it does. Okay, here we go. All right, the sun here is, like I mentioned earlier, big enough that we could fill it with about 1 million planet Earths, or we could place 109 Earths across the diameter of the sun. So we could line them up across here, about 109 Earths. And this is an actual photograph of the sun that I took a number of years ago, I think it was. And you can see some sunspots here. These are electromagnetic storms on the face of the sun. We'll look at those in detail later on. And the sun has a surface temperature of approximately 10,000 degrees Fahrenheit. And it's extremely hot there, of course, on the surface, but much hotter inside the sun at the core, and even actually hotter outside the sun in the outer regions of its atmosphere. And that's not fully understood why it's that way, but it's actually hotter out there, and it's caused by some things called heat bombs, that there's energy erupting up out of the sun, kind of like a volcanic eruption, spreading out through the atmosphere and feeding the atmosphere of the sun with energy, and that heats it up. And of course, it's not as dense out here, so you might, if we would actually go there in a bodily form, we might actually get burned quicker on the surface than we would out in the atmosphere, because the atmosphere is not nearly as dense. So not as much to carry that heat. The sun burns 600 million tons of hydrogen per second in the core of this star. So this hydrogen is being fused together to form helium. And so as this 600 million tons per second is fused together into helium, most of that mass stays behind as helium. So there's 4 atoms of hydrogen that get fused together into helium. And then this here is where most of the mass stays. But some of the mass goes missing because something needs to create that energy that the sun is giving off, and it's giving off a copious amount of energy. So the amount of energy that the sun loses every second, according to astrophysicists, is about 4 million tons. So the sun is 4 million tons lighter now than it was 1 second ago. And then there is a solar wind coming off of the sun. There's so much energy pouring out of the sun that it's carrying particles away from it. And so that's another 1.5 million tons a second that's leaving the sun through the solar wind. And some of those come to the earth and make northern lights here and southern lights at the South Pole. And so there's a total of about 5.5 million tons per second that the sun is losing. But it's not a problem. There's nothing to worry about because the sun is so massive, it's so big, that it could shine for another, apparently, 5 billion years, if the Lord would want it to, without any problem. Of course, by then, it would have gone through some changes in the life cycle. I'm sure the sun would be bigger, and it would be redder, and those kinds of things. But there's enough fuel there to last for that amount of time. This is a cutaway diagram of the sun. Kind of helps us understand how the sun looks inside. Of course, this is all based on what astrophysicists believe that it looks like inside. This is the core of the sun and the convection and radiation zones out here. The surface of the sun have these sunspots. When we have more sunspots, we have more coronal mass ejections and prominences, and we have more solar flares, things like that. What I want to do here is just throw up a graph that shows 400 years of sunspot observations. We have an 11-year cycle of increased and decreased activity. of sunspots. We have just come out of a solar minimum here. This is the year 2000 on this graph, and we go all the way back to the year 1600. So there's about 400 years here. And right here, we've just come out of a solar minimum, and we're going up into a solar maximum. So that's the reason why you see this jagged blue line. It goes up and down over a period of 11 years. So the sunspots almost disappear at the trough of the cycle. Then we have lots of them at the peak. So this has been happening throughout history. And if you smooth this line out, you have the black line, and you see how that we are in a modern maximum. And there was a blip down here where we had the Dalton minimum, and then we came down here to the Maunder minimum between the years 1650 and 1700. And this is over the time that, coincidentally, Europe recorded its coldest temperatures. And this is also in the time when there was early settlers here in the United States, and there were some extremely brutal winters over here in the United States as well. So we have the Maunder minimum, and beyond that, we can see how that there was an increase of solar activity there. So we have an 11-year cycle, and then we also have what appears to be a 300-year cycle. And somewhat unsurprisingly, if the sun has an increase in activity, the earth might just warm up a little. So there's a good chance that the earth has been affected by the increased activity on the sun in this 300-year cycle. Now, of course, the earth has huge oceans, so this can act like a heat sink, and it can absorb some of this erratic 11-year cycle here. But this long-term 300-year cycle, there's not a lot of absorbing that the earth can do to overcome that. So there is some fluctuation in the earth's temperatures, and of course there are other things that affect the earth's temperature as well. But for the most part, the change that we're talking about is just less than 2 degrees Fahrenheit. For example, from 1880 to now, the global temperature has risen about 1.5 degrees. I think that may be Celsius, or 1.2 to 1.5. So there appears to be some change, but it's very minimal. And so that is a way that God is making so there's natural balances here to counteract some of the things that make so that the earth would heat up too much or get too cold. He has the earth set up to be just right for life to exist here. Here is a picture of a coronal mass ejection in the beginning stages on the sun. So this is a huge loop of solar plasma and particles from the sun that are about to erupt off of the sun. And I'll see if we can actually get this in motion with this time-lapse photography. And we'll see if we can get it to go. Okay, here, this is kind of like in high-speed motion. And you can see this coronal mass ejection. The sun can throw off billions of tons of matter in one eruption. And that's what you saw here. I'll play it one more time. The Earth here at this scale would be smaller than my pointer up there. So it kind of gives you a sense of scale here. And the sun can throw off these enormous clouds of plasma. And if those are sent in a direction toward the Earth, then we can see northern lights or the aurora borealis. And that's what you see there. We were in Alaska a few years ago, and I went outside close to midnight to check and see if there were northern lights. And sure enough, the sky had these glowing green patterns and some other colors there too, as you can see. And so I started taking some pictures, and you can see a few of them here. And then there was another photo that was taken by someone else in Alaska, and I put that up here as well. These are particles from the sun that are coming into our atmosphere and interacting with it. So what happens is the sun throws off a solar flare and a coronal mass ejection. So now we have these charged particles that are coming toward the Earth. And these are, the radiation from the sun is actually dangerous for us. But thankfully, God has placed a magnetic field around the Earth that acts as a shield that shields us from these particles. So these particles come to the Earth, they strike the field of the Earth, the Earth's magnetic field, and they are deflected around the Earth. Then they go behind the Earth and they find gaps between the magnetic field lines, and they enter those gaps and come back to the Earth. and they follow those magnetic field lines. And since the Earth is like a bar magnet with an attraction to the north and south polar regions, they collide into the north and south polar regions of the Earth. So we have the auroral oval above the Earth and below the Earth where these particles come in. They collide with the atmosphere. They carry an electrical charge, so it ionizes the gases in the atmosphere and it makes them glow. So nowadays, astronomers have a much better understanding of what the northern lights are. They used to not really know what they were, but now they've noticed there's a correlation between the activity on the sun and the northern lights here on the Earth. If there's a coronal mass ejection on the sun, about 2 days later, our skies will light up with this wireless energy transmission from the sun. And the atmosphere has these glowing colors like you see here. Back to the sun. When you look at the sun late in the evening or early in the morning, you can see the surface of the sun that we call the photosphere. It's not good to look directly at the sun, but if you live on the coastal plain like we do down in Georgia, you can see the sun when it's low on the horizon, and it's not very bright then. And what we're looking at then is the photosphere. And this is what the photosphere looks like right here. I'll set this into motion. These are cells that are actually boiling upward, and these things are on average about 500 miles across, so that gives you a sense of scale. Each one of these little cells here, about 500 miles across. And so the sun has all this heat rising from the interior. These cells are rushing upward at supersonic speeds, so they're breaking the sound barriers. They come up and they explode out of the surface, and then they settle down again, and other cells rise up and take their place. So it's a seething, boiling mass on the sun as the heat rises from the interior, and it releases light and radiation off of the photosphere. But we can see other parts of the sun as well, and we'll look at the next layer as we go up a little higher. There's the chromosphere, and this is kind of like the lower atmosphere of the sun, where there's lots of hydrogen gases that are hovering just above the surface. And the only way we can see this is with a special filter on our telescopes to remove almost all of the visible white light. And so if we take all that white light away, we can see this chromosphere, and there's lots more large-scale activity happening there. And I'll try to, let's see here, back up again and set this in motion again. You can see some solar flares popping off over here, prominences over there on the left side. And so these are actually the sunspot regions, but they appear bright on this image since we're looking at different wavelengths. We can actually see this chromosphere with the naked eye during a total solar eclipse. The reason for that is the moon moves across the face of the sun, and it perfectly matches the size of the sun during a good total solar eclipse. Sometimes it's not quite the same size based on how close the moon is to us in its orbit. But when it perfectly blocks off the disk of the sun here, then we can see out around the rim there's a red glow, and that's the chromosphere that we're looking at. And then we can especially see these prominences around the edges, like you see here. They look like tongues of fire frozen in the act of leaping off the sun. And so that's all visible during a total solar eclipse. Now, if we go one step higher and we look at a slightly different wavelength of light, we can see the lower corona. And this is where we see the magnetic field lines in the plasma that's being carried out of the sun and looping back down in again. And let's try to set this in motion again. Whoops, sorry about that. We'll back up one more step and then go. And as you notice here, this part of the sun is rotating faster than the polar regions, so there's a differential rotation rate. It's kind of like a river flowing through here, and that's what twists up those magnetic field lines, so they get all twisted up and they eventually pop out of the surface like you see here. Every 11 years, it gets so twisted up that it actually resets. So it resets itself, and most of this disappears. Most of the sunspots go away, and we have this nice, smooth bar magnet with these perfect field lines again. But as the rotation keeps going, the magnetic field lines get twisted up again, and so there's this process that goes on. And this is something that God in His providence, again, has made so that there's a check to the way that these powerful objects would naturally gravitate to doing. So there's a reset here, and things turn back right again. So the sun generates approximately 3.8 times 10 to the 26th power watts of power. It's about 380 septillion watts. If we were to write it out in an actual number like we're used to, we see something that we're definitely not used to up here. So this is the amount of energy the sun is giving off, and since it's such a big number, it's useless to us, or it's useless to me. Maybe you're a mathematician and you perfectly understand this. If you're not a mathematician, I probably don't say anything when I try to say these numbers here and use these words. But to help us understand how powerful the sun is, the astronomers at NASA have packaged it into a neat little illustration that says that if we were to build a bridge of ice from the earth here all the way out to the sun, and if we were to make it 2 miles wide and 1 mile thick and 93 million miles long, and if we were to focus all of the energy of the sun onto that bridge of ice, it could be melted in 1 second. And another illustration that we can get is by looking at the greatest accomplishment that we as mankind have ever accomplished, and that is a hydrogen bomb. So that's the most energy that we've been able to unleash. And there was a hydrogen weapon test, or a nuclear bomb weapons test that was done here in the ocean. What we're looking at now is the ocean, and we're above the cloud tops, or we're looking down through the clouds at the surface of the ocean. And I'll set this into motion, and you'll see the bomb explode. As the bomb has exploded, you can see the shock wave moving across the ocean surface and through the atmosphere. Now that that has dissipated, we're left with this enormous mushroom cloud that's high above the cloud tops out here. There's a tsunami moving across the ocean surface that's most likely hundreds of feet tall. And we have all this ash and water falling back to the surface of the ocean. It's just an enormous explosion, a tremendous release of power and energy. But astrophysicists tell us that the sun gives off as much energy every second as 20 billion of these hydrogen bombs. And so then the next second, 20 billion more. So man's greatest accomplishment is literally dwarfed by this, by the sun that we have right next to us that we just take for granted. And it's continuously giving us this light and heat and energy. It's powerful. And we understand that when we go outside during the summertime. And even though the sun is 93 million miles away, there is an infrared radiation that's reaching us that's strong enough to actually snuff out life. There's more people that die from heat exhaustion every year than a lot of other disasters. So it's definitely a hot, seething thermonuclear furnace up there. The Pistol star is one of the most powerful stars that have been found. It's 10 million times more powerful than the sun and releases as much energy in 6 seconds as the sun does in an entire year. So this star makes the sun look like a damp firecracker in comparison. And so the star here, we don't know exactly how much energy it gives off because it's pretty far away from us. So I don't know if these figures are actually accurate or not. But one thing we can see for sure is that there's a lot of energy flowing off of this star, so much so that it's literally disgorging itself into space. You see all this red nebulosity around here. That's stellar material that's pouring out of the Pistol star. And then there's other stars that make even the Pistol star look like a misfire because they give off so much more energy. There are individual sources of light that are way across the universe. This star here is in our own galaxy. And then there is a great void of space before you get to other galaxies. And then if we leave our supercluster and go way out across the universe to other superclusters far away, we come to some single point sources of light that are extremely bright, so bright that astronomers had no idea what they were when they were first looking at them. They're called quasars. And it looks like there must be black hole-driven powerhouses in the centers of active galaxies. So they're also called active galactic nuclei. And these things are much more powerful than even the Pistol star. So these things are praising the Lord in their own way. Praise ye him, sun and moon, praise him, all ye stars of light. Let them praise the name of the Lord, for he commanded, and they were created. That's from Psalm 148. Okay, now we'll take a look at the planets, and we'll see how that they are put together in our solar system in a creative way. Mercury is the first planet that we look at as we leave the sun, and this is an actual photograph of Mercury, but this was just a loss of data coming from the satellite, so that's not an actual feature on Mercury, it's just a loss of data. It travels at 30 miles per second in its orbit around the sun, and this is important for Mercury to have that speed in orbit around the sun. The Earth's orbital speed is about 18.5 miles per second, and that's just the right speed for the Earth. We'll have more on that later on. It has an 800-degree temperature in the daytime and a 280-degree below zero temperature at night. These are all Fahrenheit measurements, so for those of you coming from Canada, I'm sorry that I'm using miles and Fahrenheit and things like that, but that's what we're used to down here. So we have a planet that's extremely hot in the daytime, extremely cold at night, and the reason for this is there's no atmosphere to hold the heat during the daytime, during the nighttime, and it has an extremely long day-night cycle. So if the Earth weren't set up just the way it was, then we would have the same situation as Mercury has. So again, we see divine intervention going into making so that the Earth here can support life. The next planet that we come to is Venus. And Venus is always covered with clouds like you see here. It has the brightest light in the night sky, the brightest point of light. It's not an actual star, but it looks like a star. And when you see it, it's not always visible in the evening. It's not always visible in the morning, but sometimes it is. And when you see it, it completely outshines all the other stars and planets in the night sky. It has clouds that are made of sulfuric acid, and this is the same type of acid that we have in our vehicle batteries, and it has an atmospheric pressure of 1,323 pounds per square inch. That's over a half ton of pressure crushing down on every square inch of the planet's surface, and it has a temperature of 860 degrees Fahrenheit. That's twice the heat of a conventional oven. So it's an extremely inhospitable place. It's right next to the Earth here in its orbit around the sun, but even so, it still can't support life. And it can't even support robotic planetary exploration very well unless things are done just right. The Russians sent a series of spacecraft up to Venus, and they tried to get the spacecraft to send back data from the surface of the planet, but they couldn't do it. The planet kept destroying the spacecraft until the seventh try, and the Venera 7 spacecraft was actually able to make it all the way to the surface and transmit some data for about 20 minutes, I think, before it was completely destroyed by the atmosphere there. So there's tremendous heat, an awful lot of pressure, and there's this acid, this corrosive acid. The clouds actually drop rain, but since it's not water, it's acid rain that's falling. But it's so hot down close to the surface that the acid vaporizes before it even reaches the surface and goes back up in the atmosphere again. So there's this continuous circulating bath of acids around this planet. There's volcanoes here, and there's all sorts of things like that. So I doubt you'll ever find astronauts volunteering to go to Venus, but if they would need to make sure it's well done, or else the astronauts would be well done when they get back. This is a very inhospitable place, even though it's close to the Earth here. If we take the clouds away from the planet, this is what it looks like. There was a spacecraft that was looking at Venus through radar wavelengths, or with a radar camera, and so they were able to look through the clouds and see what the surface looks like. Definitely looks like the description that we get of the planet. We'll skip the Earth here, but we'll stop by the moon. And as the moon comes up closer, you can see how that it's being resolved into lots of craters, mountain range, maria. Things like maria is the Latin word for seas. And so those are the dark areas here. Here's a mountain range called the Apennine Mountains. This is the crater Eratosthenes. We can zoom in on that and we can see a better view of it. This is what you might see through a medium-sized backyard telescope. If you ever get a chance to look at the moon with binoculars or a telescope, definitely do that because there's lots of things to look at. Over here on the right side of the moon, there's a heavily cratered region, and there's one specific area where there's the crater Clavius. It's a large crater with a semicircle of 5 smaller craters in the crater floor. Like I mentioned last evening, the moon is actually slowly moving away from the Earth, and I've got a little illustration here to help you understand how this works. So the moon is gravitationally attracted toward the Earth and the Earth to the moon. So there's an attraction here. So for that reason, the oceans around the Earth, since they're liquid, they can actually move toward the moon. So that's why we have tides coming in and going out around the ocean, because the water of the ocean is trying to go toward the moon. So it's following the moon here. So this tidal bulge is actually pointing toward the moon. But you see on this picture here, the tidal bulge is not actually pointing directly toward the moon. It's actually pointing out here. The reason for that is because the Earth is rotating this direction, and so it's dragging that tidal bulge forward. And the tidal bulge keeps washing backward, trying to come back toward the moon. And so that's why we're experiencing the high tides as we come into these areas on the Earth as the Earth turns. And with this happening, with the Earth turning and having that water washing over it all the time like that, it's making so the Earth is slowly slowing down in its rotation speed. Not by much, but it is by a little. Well, that energy isn't lost. It has to go somewhere. So the energy goes into pushing this tidal bulge forward. And since the moon is sitting right out here and having more mass up this direction, less mass down here because of the way the tidal bulge is, then it gives the moon an acceleration forward. So there's more gravitational force here than there is back here. So the moon is accelerating, and the moon's orbit is getting slightly bigger every year, a little over an inch bigger, or the moon moves away from us about an inch every year, a little over an inch. So it's another way of showing how that God has this settled at such a great degree of accuracy and precision that the moon, if it weren't for this stealing energy from the Earth, would basically sit right there perfectly in orbit around the Earth, an extremely stable orbit, and would come back to the very same place after every 29-day orbit. Mars is the next planet that we come to. It has a surface that contains iron oxide, which is just another word for rust. And there's so much rust here that you can see it from the Earth without a telescope. If you look at Mars one night without a telescope or binoculars, you can see there's something different about that star-like object that distinguishes it from the other stars, and that is that it looks orange. It has this reddish-brown hue, and the reason for that is because you're looking at lots of rust. So there's lots of rust on the surface of this planet, and it has a canyon that's 2,500 miles long, 4 miles deep. That's about 4 times deeper than the Grand Canyon here on the Earth. And it's big enough you can see it from space, like you see on this image here. So it has these extreme geologic features on Mars. Then it has other things like a volcano that's 17 miles high and 370 miles wide, so it's about 3 times higher than the highest mountain on the Earth. And the name of the mountain is Olympus Mons. It's a volcanic mountain. And up there at the top, you can see a polar ice cap. That's something that you have right here in Glacier, I guess. There's an ice cap that stays here all the time up there on the mountains. And from what I understand, it gets really cold here. And on the way up here yesterday, I heard that there was a record set here in Montana where the temperature got down somewhere around 70 degrees below zero, which is just amazing to me. I have no idea what that would even feel like. But that's cold, so I understand you get really cold here, but I doubt that you get so cold up here that the atmosphere freezes and settles on the surface of the planet. That sounds kind of absurd to actually say that, but that's what happens on Mars. Mars gets so cold that the atmosphere up here around the North Pole and the South Pole gets so cold that the air freezes into a solid form, and falls down to the surface. So this, what you see here, is dry ice. It's frozen carbon dioxide. The next planet that we come to, actually I might have a few more pictures of Mars. This is what Mars looks like through a 16-inch telescope with a somewhat sophisticated photography method called lucky imaging. And that is where you take a video camera, attach it to the telescope, and you get lots of frames. The camera I used here was a camera that was specifically designed for planetary photography. And so it captured about 100 frames per second. And that's important. And the reason for that is because the atmosphere has a lot of turbulence. And so when you're looking at Mars through a telescope, it's shimmering and wiggling and it's being smeared out. It's kind of like a bowl of Jell-O that can't hold still. And that's just because of all the atmospheric turbulence that you're looking through. But when you take 100 frames per second, it can freeze that wiggling motion and you can get a better view of it. And then computer software can pick out the best 10 or 20% of the images, stack them all together, and increase the signal to noise ratio, and you can sharpen it to this extent. So you wouldn't be able to see a view this good of Mars through a telescope eyepiece, but this is what the telescope's potential actually is. I used a 16-inch telescope to take this picture. Now these are pictures that were taken by a spacecraft that was orbiting around Mars, and you can see there's black sand dunes over here. Here's some other sand dunes, and there you see streaks sliding down the sand dunes. Those are kind of like landslides there. And then you see these twisting black lines. These are called by whirlwinds that are meandering across the surface, sucking up the lighter colored dust and exposing the darker colored dust beneath. This is believed to be a sand dune with, jets of gas spewing out of the dunes there and staining the surface. Next we come to Jupiter, and if you look at Jupiter through a telescope, this is about what it looks like. It looks like one small bright planet and 4 other star-like objects moving right with it. Those aren't stars, those are actually Jupiter's moons, the Galilean moons, and they are orbiting around Jupiter, so they don't always have this same orientation. Some of the time, they might all be on one side of Jupiter. Sometimes there's 3 on one side and 1 on the other. Sometimes one is behind the planet, so you might not see it. One might be right in front of it. But they're orbiting around Jupiter. And another thing you will notice is that there are a couple of dark streaks across the face of Jupiter. Those are Jupiter's main equatorial cloud belts. And another thing you notice is Jupiter is disappearing. And the reason for that is because the Earth is rotating at 1,000 miles per hour at the equator, so it's dragging our telescopes away from whatever we're looking at. And so it looks like the objects are moving out of the field of view. So for that reason, it's handy to have tracking motors to keep the objects aligned or centered in the eyepiece. And another benefit with that is that you can usually have a go-to function as well. You can punch in what you want to see, and the telescope will go find it on its own, after you set it up right, of course. So this is what Jupiter looks like through a 16-inch telescope with the lucky imaging method of photography. Like I mentioned earlier, with this one, I had 10,000 frames total, selected the best 15% of those. The computer did. I didn't manually, laboriously pour through those or sort through those frames, but it selected the best 15% and stacked them together. And this was taken in 2018. You can see the great red spot there. That's a huge storm that's been there ever since astronomers were looking at Jupiter through telescopes. All right, here's something else that you can see. And what we have here is one of Jupiter's moons that's orbiting around Jupiter, and it's casting a shadow on the surface of Jupiter. So there's basically an eclipse happening here, and this moon is blotting out the sunlight and is keeping it from falling on Jupiter's cloud tops. There's another thing that you can do here. If you can see a screen that's almost directly perpendicular to your face and not on an angle, you can actually cross your eyes and you can see a 3-dimensional view of Jupiter. So it's a crossed-eyed 3D view. If you could just try to look at your nose or look somewhere close to your nose, as if you were holding your finger in front of your nose, then instead of seeing 2 Jupiters, you actually see 3 of them or 4. And what you want to do is make so that 2 instances of Jupiter merge together right in the center. And if you can get them to merge by crossing your eyes, like you're looking towards your nose, then these will actually look like 3-dimensional spheres up there. So the way this was done is you just take one picture of Jupiter here, and then about 30 minutes later, you take another picture, and so that gives you what you need to stack them side by side and get a 3D view if you can do that. So again, this is an eclipse happening on Jupiter. And then this here is another picture of Jupiter. It also has an eclipse happening on it, but this was taken by I think it was the Voyager spacecraft that took this image. Jupiter's gravity is 2.4 times stronger than the Earth's gravity, so that means that a 200-pound man on the Earth would weigh 480 pounds on Jupiter, so it's not necessarily a place to go if you're on the Weight Watchers Club. And then it has a rotation speed of 29,000 miles per hour at the equator, and it has a great red spot, and that's the name of that storm over there. This storm is big enough that you could place 2 Earths across the storm system. Now, the storm has shrunk in size since this picture was taken, but it's more of a circular shape now instead of an oval. It has actually gotten a little taller and less broad. It's basically a giant hurricane that's been there for probably at least 200 years. Here's another close-up view of an eclipse happening on Jupiter. And this is a picture of something that astronomers saw in 1994. They saw not just one object in the night sky, they saw a whole string of comet-like objects. And so this, of course, got their attention. What in the world was going on here? It looked like a string of over 20 objects orbiting through our solar system. And so they started studying the orbit of this, and they noticed as they traced the orbit backward that this comet came too close to Jupiter. So what happened was this used to be a single comet, and it came too close to Jupiter at one point in its orbit, and as it sped over the surface of the planet, it had a tremendous kinetic energy to cause it to keep on going, but at the same time, Jupiter, with its powerful gravity, started to pull back on this comet. So there's this cosmic tug of war where the comet wanted to go on its merry way, but Jupiter pulled back with all its gravity, and it was so much of a force there that the tidal forces literally ripped the comet into all these pieces. And so the comet kept on going then, but some of the pieces started lagging behind, and these pieces all started orbiting away from Jupiter. But astronomers, as they studied the orbit, they noticed that there was no way that they could escape from Jupiter's gravity. Jupiter had locked onto these pieces, and they had gone away from Jupiter, but they were destined to return and come back toward Jupiter again. So that time, when they were coming back toward Jupiter, astronomers were ready and they were watching. They trained their telescopes on this planet as these particles or pieces of comets came plunging back toward Jupiter again, and this time Jupiter swallowed them whole. And you can see the images here. This is the first image. It shows an enormous explosion there. This is hundreds of miles high. And then there's the aftermath here. You can see these dark scars that were left on the surface of the planet. And these are actually thousands of miles wide. So enormous explosions here that happened when these things collided with Jupiter. And this happened again later on. There was an amateur astronomer a few years later that noticed another bright flash on Jupiter. Jupiter had swallowed up another asteroid or a comet. And Jupiter is doing this all the time. And that's important because there are things out there that don't have stable orbits, maybe some things that come in from outside of our solar system, and they are a threat to the Earth. If something of this size would hit the Earth and we'd have a mushroom cloud that would extend up hundreds of miles high like this, then of course that would be devastating to life here on Earth. But Jupiter is out there in the outer regions of our solar system eliminating these threats before they even get to us. And so this is part of the providence of God. These things out there are actually working together to preserve life on earth, according to God's decree. Jupiter has a moon that's right next to it. It's called Io, and it's the most volcanically active world in the solar system. The reason for this is because it's close enough to Jupiter that Jupiter actually causes ground tides on this moon. So there's no liquid surface on Jupiter's moon's Io, but the crust itself actually rises and falls and breaks open, and lava spews out. And so there's lava spewing out a couple hundred miles high. Here's another volcano. There's another volcano. So this moon is just constantly turning itself inside out as it's orbiting around Jupiter. The next planet that we can look at is Saturn. And I'll show you what it looks like with a small telescope. That's about what you could expect to see through a small backyard telescope. You can see the rings of Saturn, so that's really interesting to see. Saturn is one of the best things to look at. In my opinion, if you have a chance to look through a telescope, the three top things to look at are the moon, Saturn, and a globular cluster. So remember that if you ever have a chance to look through a telescope. And then over here on the right, there is another picture that this is about what you could see looking at Saturn through a medium-sized telescope, maybe at least an 8-inch to 10-inch telescope on a really good, stable night. But if you have a bigger telescope, like a 16-inch, and you use the video photography method, then you can get a view like this. So it's amazing to see how that God has opened up access to the universe like we have today, whereas men in the past haven't had that same opportunity. Now, of course, if we have a spacecraft out there next to Saturn, we can get an even better view. So this image here came from the Cassini spacecraft that was orbiting around Saturn, but has since plunged into the planet after its usable life was over. They caused it to actually dive into the planet itself. The rings are made of ice particles. So they're not solid rings. You couldn't stand on them. Now, you might could stand on some of the ice particles there, but they're made up of lots of individual ice particles and some rocks. They are ranging from just small table salt-sized grains all the way up to house-sized boulders. And they're orbiting around the planet. And they keep their orbit well enough that they disappear from view every 15 years. They basically disappear when they tilt edge on toward us. There's an ocean of chemicals here, and Saturn is actually kind of like a light planet. It has a lower density than water itself. So theoretically, you could get Saturn to float temporarily until the mass of the two objects would cause them to assimilate together into one sphere, because Saturn's density is only two-thirds that of water. Here we can get a close-up view of Saturn's rings, and you can see how they're made up of hundreds of individual ringlets. As we go across here, this is a big gap that's called the Cassini division, and that's another gap called the Encke gap. And this Cassini division is caused by a moon that's way out here. It's about twice as far away from the planet it would be 3 times farther away from the planet than this Cassini gap is. But the gravitational pull of that moon way out there actually clears out this region. So there's a 2-to-1 orbital resonance here, and it makes so that this is an unstable region. So all the ice particles that get into that region are kind of thrown out. So it clears out that region. Same thing is happening here. There's a gravitational effect here that's clearing things out of the Encke gap as well. Here's a view of how the rings are casting shadows on the surface of the planet. So the sunlight is filtering through the rings as the day progresses on, and the shadows are being cast across the surface of the planet. There's auroras on Saturn. Even though Saturn is 9 astronomical units away from the sun, 9 times farther away from the sun than the Earth is, there are these lights on Saturn as well, where the sun's particles enter the atmosphere and ionize the gases. Here's a couple of Saturn's moons, Dione and Mimas. You can see them superimposed against the backdrop of the planet itself and the ring system. Here you can see it again. These rings are almost completely edge-on, and there's the moon itself. You can see the sunlight filtering through these ring systems. And these are just perspectives showing God's creativity, and it looks almost like some form of artwork here. Here's another view of 4 of Saturn's moons. There's a big one in the background. There's another one here. There's one just outside the field, or the ring system. And here's the tiny moon Pan, I think it is, nestled inside the Encke Gap. Here's a storm that was orbiting around Saturn. You can see where it was earlier. It orbited all the way around the planet and came back around and it made one complete rotation. Saturn has a moon called Enceladus. It has enormous geysers, and they launch vapors into space. And so I know you have a big geyser down south of here, Old Faithful, but this one here, these geysers launch these gases and liquids right into space. There's another moon around Saturn that has a pock-marked appearance. It looks kind of like a potato. It's actually lighter than water because it's so porous. There's lots of empty space here in this interesting moon. Here's another one that looks like a walnut, and the reason for that is because it has a mountain range around here. It's 800 miles long and 12 miles high. And it also has a crater that had a landslide, and part of the crater wall collapsed inward and made that appearance there on that crater. So there's lots of interesting things happening in the solar system all around us, just like we have those same forces happening here on the Earth. Uranus rotates on its side, so this here is kind of interesting, but it's also a problem for the evolutionary theory of the formation of our solar system. That theory states that there was a protoplanetary disk of dust that was spinning, and most of the dust and gas started to coalesce toward the center, and that's what formed the sun. And then there were other eddies that formed out farther in the disk, and those formed the planets. Well, if that were the case, we would expect to see them all spinning the same direction, the same way that the original disk was spinning. But Uranus doesn't do that. It's actually rotating backwards, as well as one of the other planets. And another thing is that Uranus rotates on its side. So there's a couple of problems for that evolutionary model for our solar system. And this happens over and over again when mankind tries to postulate ways that the universe could create itself. There's so many issues that they run into and problems because we can't have anything just making itself and appearing on its own. There's a blue-green color here that comes from the methane atmosphere, and it has this planet has 27 moons and 9 rings around it. So you see more creativity here, again, more variety. But of course, those are outside the field of view that we were looking at there. One of the moons around this planet are called Miranda, and it has a jumbled terrain and has the largest cliff in the solar system. And we can zoom in on that here. The cliff is anywhere from 3 to 6 miles high. It's circled with a red circle there now. The next planet is Neptune. It's composed mainly of hydrogen and helium, and this planet has the fastest winds in the solar system. They're moving at up to 2,200 feet per second, or 1,500 miles per hour. And you can see some of the cloud bands being carried around the planet here in this close-up view. The next thing that we come to is Pluto, and Pluto has been imaged up close for the first time just recently when the New Horizons spacecraft went past it and got these images. One of the most surprising things for astronomers about Pluto was that it looked relatively young. They figured that it would show signs of extreme age with it being so far out in the solar system, but in effect, they were wrong on that, and there's lots of signs of relative youth on this planet. We won't go into the details of that now, but here's a close-up view of part of the surface, and there are more close-up views of the planet that we could look at, but we won't. 370 to 390 degrees below zero is the temperature of this planet. It's so far away from the sun that it has a 247-year orbit. And this orbit is the reason it has such a long orbit is because it's so far away from the sun. It's almost 40 times farther away from the sun than what the Earth is. So it's way out there, and it's just a small object. And so it actually kind of got itself into a little trouble because of that. It's not really big enough to be considered a planet. It's about half the size of the U.S. So the International Astronomical Union decided to come up with a set of criteria of what an object has to meet in order to be considered a planet. The reason they decided they needed to do this is because they started finding other objects out past the orbit of Pluto, and one of them was even more massive than Pluto itself. So do they add that to the number of planets, or do they leave it? Or what? Those are the questions they faced. The set of criteria that they came up with was, first of all, it has to orbit the sun. The object has to orbit the sun in order to be considered a planet. Secondly, it has to have enough mass, creating enough gravity to pull itself together into a spherical shape, which Pluto does. And thirdly, it has to have enough mass, creating enough gravity to clear out its orbit, just like Saturn's moons that were clearing out those regions in the ring system. Well, Pluto didn't sufficiently clean out his orbit, and so he lost his planetary status, actually had his official designation changed to just a number instead of a name, 134340, and he was kicked out of the planetary club, and there he sits. So, poor Pluto. But he still hangs on to the name just a little. It's called a dwarf planet, along with two other objects that were formerly considered to be asteroids. Romans chapter 11, verse 33 through 36 says, "Oh, the depth of the riches, both of the wisdom and knowledge of God. How unsearchable are his judgments and his ways past finding out." Skipping down, and well, we'll just go ahead and read. "For who hath known the mind of the Lord, or who hath been his counselor, or who hath first given to him, and it shall be recompensed unto him again? For of him, and through him, and to him are all things, to whom be glory forever. Amen." So God used his great wisdom and knowledge and power to create all these amazing things in our solar system. And so as we recognize this, we understand that all glory and honor, power and strength are to be given to him through all ages to come. And then, of course, we know what the next verse says. Romans 12, verse 1, "I beseech you therefore, brethren, by the mercies of God, that you present your bodies a living sacrifice, wholly acceptable to God, which is your reasonable service." Psalm 147:4 says, "He telleth the number of the stars, he calleth them all by their names. Great is our Lord, and of great power. His understanding is infinite." Comets are also a part of our solar system, so we'll take a look at them here now. What you're looking at here on the screen is something that you might have seen just a couple of years ago. So there was a comet that came through in 2020, and it was named Neowise. Have any of you here seen that comet? And okay, I see a few hands. Okay, good. So in the night sky, comet Neowise looked like this, or this is an actual picture of it, but this was taken through my 10-inch telescope, so it looks bigger and brighter here than what you saw with the naked eye or through binoculars. But this one was bright enough that you could see it without any kind of optical aid back in 2020. And then there was another one that came through just, I think it was 2021, yes, last year. I'll show a picture of that later on. But what we want to do next here is take a look at how these comets behave in their orbits around the sun. And we'll use Halley's Comet for an example. Halley's Comet has a highly elliptical orbit, so it comes from far out in the solar system, and it whips around the sun right here and goes back out again. So we only see it once every 76 years when it comes into the inner solar system here. And when it does that, the sun heats it up enough that it starts to melt the comet nucleus. The nucleus is the solid part of the comet, and it's been nicknamed a dirty snowball because that's basically what it is. It's frozen water ice, gases, and dust. And as the sun heats up that nucleus, it pushes the debris off the comet, and that's what forms the tail. Now, these particles are being pushed off the comet, and the comet is becoming smaller with each pass around the sun. And so if the solar system were actually 4 to 5 billion years old, like what's claimed, all the comets should be burnt out by now. And the only way that we should still see comets today is if they are being replenished from somewhere that we have no evidence of or are not able to see them. So this is another interesting thing to notice. The paths that the comets take, these orbits, are filled with debris from the comets. So there's lots of rocks and gravel that are still orbiting on these paths. So we don't see Halley's Comet every year, but we do see parts of Halley's Comet whenever we cross the orbit of Halley's Comet right here, and again right over here. So this happens in the spring, this happens in the fall. And when we cross those orbits, then we actually have a meteor shower. So there are particles that rain onto the Earth's atmosphere, and they look like falling stars. So this here was the comet that came through last year. This one was just barely visible, so it was hard to see. But I took a picture of it when it was passing through the Whale Galaxy and the Hockey Stick Galaxies, or it was passing through that region from our perspective here. Now here's a picture of a background of stars, and I have some simulated falling stars coming through here. But this is kind of what you see during a meteor shower. You see stars flying through the atmosphere, star-like objects, but they're not actually stars, they're just bits of rock. A lot of them are about the size of a grain of rice or a pea, just small chunks of gravel that come into the atmosphere at speeds anywhere from 10 to 50 miles per second. And it's fast enough for them to create enough friction to heat up to the point they literally vaporize. So you're seeing not the rock itself, the rock is too small to see, but you're seeing it vaporizing in a brilliant flash of light and ionizing a shaft of air about a foot or two in diameter where it just zipped through. So these things, they can move at up to 100,000 miles per hour as they come through the atmosphere and they burn up. But they don't always burn up before they hit the surface of the ground. The ones that come from the annual meteor showers, they normally do burn up. But some of the bigger meteoroids that are out there and asteroids, they can pass through the Earth's atmosphere with enough energy that there's not enough time for that ablation to happen where all the outer layers get burned off and you can have the rock actually strike the Earth. That's what happened in Arizona at the Beringer Crater. It's about 3/4 mile across from one side to the other, and it's just this neat hole punched right in the ground because of an asteroid that was estimated to be anywhere from, I think it was 50 to 100 yards in diameter. Then there was another incident that happened in the Tunguska region of Siberia, Russia. In 1908, there was what was believed to be probably a comet, maybe an asteroid, that came into the atmosphere above Russia, and it exploded. And it was such a tremendously large explosion that it leveled 800 square miles of forest. It knocked the trees down in a direction away from the epicenter of the blast. And it was in a largely uninhabited region up there, so there wasn't a lot of people that saw it, but there were some science expeditions that went up there later on gathering evidence from what happened. They never found the actual asteroid. It just obliterated itself in the atmosphere. These things, when they come and strike the atmosphere, there's enough forces at play that they can actually break apart. If you take an ice cube and drop it in a cup of water, the ice cube can crack. And that's kind of what happens here with these comets. They're out in the frigid, cold outer space, and when they strike the Earth's atmosphere, there's lots of heat from that friction as they pass through the gases in the air, and so that can cause them to heat up and crack open, and there's such a great deal of resistance there too. It's almost like the comet hitting a brick wall when it hits the atmosphere, so that can help to set off this explosion as well. And then more recently, just within recent memory, I think maybe close to 10 years ago, there was another meteoroid that came in over Chelyabinsk, Russia. It was actually a meteor as it passed through the atmosphere there. It left this smoke trail, that's ionized rock that you see there, or a cloud of particles left behind. And they actually discovered that the meteor fell into a lake then just beyond this town. And when this thing came over, it caused sonic booms and explosions that actually sent quite a few people to the hospital. About, I think it was, I can't remember the figure anymore, I'm sorry. Quite a few people had to go to the hospital. It caved in a factory roof. It knocked out lots of windows. And so it was caused by a rock that was estimated to be about 40 feet in diameter. So this happens every once in a while, but thankfully, God has the atmosphere that eliminates most of these threats, and he also has Jupiter out there that eliminates those even larger threats. As we read earlier this morning, there's a great God in control of all these things. There's so much that he's got going on out there, so many things he's controlling, so many things he's done. And here we are on this planet, and we have our own little lives, and we have our own little problems. But to us, they seem big, and to us, they seem overwhelming sometimes. And here in Isaiah, we are being implored to remember something. Have you not known? Have you not heard that the everlasting God, has it not been told to you from the beginning? Have you not understood from the foundations of the earth? It is he that sitteth upon the circle of the earth, and the inhabitants thereof are as grasshoppers. So we are so small. God is so big, he can take care of every problem that we have. And then it goes on to say that even the things that we think are great, he can bring them to nothing. He brings the princes of earth to nothing. He maketh the judges of the earth as vanity. But then he invites us to look to him. Have you not known, have you not heard that the everlasting God, the Lord, the creator of the ends of the earth, fainteth not, neither is weary. There is no searching of his understanding. He giveth power to the faint, to them that have no might, he increaseth strength. Even the youth shall faint and be weary, and the young men shall utterly fall. But they that wait upon the Lord shall renew their strength. They shall mount up with wings as eagles. They shall walk and not be weary. They shall run and not be weary, and they shall walk and not faint. So that is our God empowering us to do his will. As we look at all the wonderful and the mighty things that God has done in the universe around us, then we're just left thinking, if God be for us, who can be against us? And there is no good thing that he holds from them that walk uprightly, is a promise that we have. So as God has provided for us, we should be grateful, and we should be willing to have our lives committed to him in return as well. And we're thankful that God cares for us in this way. All right, I think that's about all I have for now. I want to shut this down earlier than what we did last evening because of being able to get down there in time for the meal. But I do have a time here for questions. So the next thing we have here is a Q&A period. So if any of you have any questions, feel free to fire away with your questions. I'll try to answer them if I can.
Do you have any studies on UFOs?
Do I have any studies on UFOs? Okay, I guess that's a good question. No, not myself. I guess that's not really what you're referring to, though. But there are quite a few unidentified flying objects that are reported to some of the centers that take those reports. And one thing that's interesting is that when the planet Venus is at its maximum, that is when the UFO reporting centers have their highest volume of calls. So that kind of shows us that there are a lot of natural explanations for a lot of these UFO sightings. One reason why the planet Venus is considered to be a UFO at times is because it's so bright that it's still visible when it's setting down close to the horizon. Usually, stars, they have this, what's called an atmospheric extinction. As they shine through more and more air as they get close to the horizon, their brightness decreases, and it looks like they go out. The light goes out. The Venus is so bright that it's easily visible even if it's sitting all the way down on the horizon. So what happens during that time, Venus light is shining through so much air and atmospheric turbulence that it's being refracted into lots of different colors, and it's flashing. It's flashing through red, green, blue, yellow, all those different colors. So it looks like a craft with bright lights that's landing on the horizon. And so it looks like an unidentified flying object that's coming down. And when it's that close to the horizon, you can actually see its motion as it settles down to the ground. There are other things, too, that could be explanations for UFOs. There are quite a few satellites out there that are moving across the sky. There are some satellites called iridium satellites that actually have reflector dishes that point downward to the earth. And if those dishes catch sunlight at just the right angle, they will cast a spotlight beam down to the earth. So as they're moving across the earth, they're shining this spotlight beam of light. So from our perspective, what it looks like, if we're in that path, we can look upward and we can see an extremely dim star that all of a sudden gets much brighter, a blazing brightness, even brighter than the planet Venus. And then after a few seconds, it disappears. And so that looks kind of suspicious too. There's quite a few sightings that people have of UFOs they claim to have, but that's basically what they are, unidentified flying objects. Just recently, there was the U.S. Navy in the last year or two released quite a bit of video files, video footage and things like that of unidentified flying objects. And there were some photography specialists that as soon as they saw them, they knew exactly what they were looking at. They were looking at refraction and reflections within the camera lens and things like that. So that accounts for a lot of it, but I have not seen all UFO sightings, and so I don't know what they're all like, and I'm sure that there could be some sightings where there's not a good and appropriate explanation that's just ready to go, but it is interesting to see the things that are out there in the universe around us. Yes, Tom.
I understand that we only receive a very small percentage of the sun's energy.
Mm-hmm.
We see some of that harnessed in solar panels and so on. What happens to all the other energy that's not received by the Earth?
Good question. So the energy that's not received by the Earth is just sent out into this, the solar system around us, and it seems like it's wasted. But in reality, it's not. It's going out and it's forming a sphere around our solar system. It extends far beyond the Earth and Jupiter and Mars and Saturn. And it's way out there. It's called the heliopause, is the boundary of that sphere. So it's where the sun's influence stops and the influence of interstellar objects actually starts. So the sun has a magnetic field, it has this radiation that's going out, it has a solar wind that's going out, and it's blocking a lot of the particles that are coming from deep space. And so that's actually protecting us. There are different types of rays and things like that the sun's influence here around us, those rays are being attenuated because of the sun's influence here. Anyone else? Okay, if not, I think that's all I have. And I guess, Wendell, you're planning to close, is that right?